Okay, is the screen is visible properly?
Yes, sir.
Okay. Achha, today our topic is resistance temperature detector, that is called RTD. Okay. So what is resistance thermometer, which is also known as resistance temperature detector? It's a kind of transducer. Okay. So it's a basically the definition of this device is it's a device which is normally employed to find out the temperature. Okay, to find out the temperature by measuring the resistance of pure electrical wire. Clear? So pure electrical wire and its resistance and its temperature can be find out or obtained with the help of this RTD. So the objective of using this kind of instrument is to measure the temperature of pure electrical wire. In different electrical applications, the temperature of the transmitting device, that is the wire, is specified. Say for a specific usage, if the temperature will go beyond a certain or specified value of temperature, then there will be some problem in the operation. So in order to keep the temperature of that particular transmitting device, that is the electrical wire, we need to time check out its temperature. Okay, so for this kind of application, RTD or resistance temperature detectors are employed or used. So basic objective of using this device is this. So this where is referred to as temperature sensor. Basically it sense the temperature. Now if we want to measure temperature with high accuracy, in sometimes in some applications, some accuracy level, some sort of precision level is needed to find out or to measure the temperature. That is, if for example, consider, so for a particular electrical wire, say the temperature is 40 degree. Say for a particular application or usage, the temperature of the conducting wire is 30 degree exact temperature, but there are some devices are available which cannot measure the temperature properly or with accuracy or accurately. Say it is measuring, it is I am applying a thermometer kind of device to measure the temperature of that wire, but it is showing say 29.5 degrees Celsius or 31.2 degrees Celsius, like this. So this kind of measurement can be treated as exact or accurate measurement. So for more accuracy, RTD is needed. Okay, so it is one of the strongest solution for the industrial application. Now it should be mentioned in this context that a good linear characteristics a good linear characteristics over a wide range of temperature, it has a good linear characteristics over a wide range of temperature. That means the RTD which we employed to measure the temperature of the wire has a linear change of its resistance over a change in टेम्परेचर फॉर ए लॉन्ग पीरियड. ओके, मतलब इसका टेम्परेचर अगर चेंज होगा, से यू कैन सी हेयर इन द डायग्राम कि टेम्परेचर चेंज होने से इसका जो कैरेक्टरिस्टिक्स, इसका रेजिस्टेंस का जो चेंज होता है with the change in temperature corresponding change in resistance is almost linear for a specific period of temperature change. Am I clear? So this is a basic characteristics of the RTD. So in the MCQ, this kind of question may be given that what the characteristic temperature resistance characteristics of the RTD. Uh, Option number one, linear, non-linear, none of these, both one and two, or both A and B. So to answer this kind of question, you must remember this kind of crucial points. Okay. So next, by this equation, you can see here that variation of resistance of metal with the variation of the temperature. So here, with the help of this equation, you can see the basic relationship between the change in resistance with the change in temperature. So here in the left hand side, you can see one resistance value is there, RT, okay, R suffix small t, which is equals to R0 R naught within third bracket 1 plus in first parenthesis t minus t0 plus beta t minus t0 whole square plus dot 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 and so on. The series will continue, where RT and R0 are the resistance value of the RTD material at T degree Celsius and T0 degree Celsius. Okay, alpha beta constants depends on the metal. It varies from metal to metal. This expression is for huge range of temperature. Okay, मतलब temperature का जो मतलब से T0 is say 10 degree Celsius and RT is say 250 degrees Celsius, like this. For a huge range of temperature, this kind of relationship is applicable. But when the temperature change is very small, say 10 degree and 12 degrees Celsius, then the expression will be approximated and it will as RT is equals to R0 1 plus T minus T0. So you need to remember the this one, the second one mainly. So with the help of these two uh, set of equation, we can find out the resistance value of the RTD material for large change in temperature and for small change in temperature. Clear? Any doubt till now?
No, sir.
No, sir.
Okay. So basically what you need to learn from here, you need to remember the definition of RTD, the purpose of using RTD, two equation which can relate that resistive value or the resistance of the RTD material for small change in temperature, the second one, and for huge large change in temperature, and these characteristics obviously. So variation here, some we are showing, we have plotted some the property, the characteristics of the RTD material and their change in resistance value with the change in temperature. For example, platinum, copper, nickel. Also in this regard, I can suggest you this thing you need to remember and you shouldn't miss. What are the example of RTD material? Here you can find three RTD materials are given: platinum, copper and nickel. So MCQ के लिए ये सब question भी important है. Now the most important thing, how do RTD work? Okay. नॉर्मली पहले तो सब्जेक्टिव टाइप डिस्क्रिप्टिव टाइप क्वेश्चन आता था इससे, शॉर्ट नोट या 5 मार्क्स और 7 मार्क्स का. तो अभी तो एमसीक्यू आने का चांसेस 90% है फॉर द अपकमिंग एग्जामिनेशन. सो थॉरोली ये सब तुम लोग को पढ़ना होगा. नाउ आई एम एक्सप्लेनिंग हाउ आरटीडी वर्क और हाउ डज ए आरटीडी वर्क. RTD, resistance temperature detector. Okay, so it works on a basic correlation, an interrelation between metals and temperature. As I told earlier, a basic property of the metal is that with the change in temperature, its resistance also will get varied. That means change, either increase, जिसका positive temperature coefficient increase होता है, और नेगेटिव टेम्परेचर कोएफिशिएंट ये जो मटेरियल का है उस सब के लिए द रेजिस्टेंस विल बी डिक्रीज्ड. ओके, विद द इंक्रीज इन टेम्परेचर. So basic relationship between resistance and temperature of the metal is the key of the working of RTD. Clear? Now, as the temperature of a metal increases, the metal's resistance to the flow of electricity increases. As the temperature of a metal increases, the metal's resistance to the flow of electricity increases. Simply, temperature ज़्यादा करो, resistance ज़्यादा होगा. Similarly, as the temperature of the RTD resistance element increases, the electrical resistance measured in ohm increases. So temperature increase, resistance increase. RTD elements are commonly specified according to their resistance in ohms at 0 degree Celsius. The most common RTD specification is 100 ohm. मतलब resistance RTD material का 100 ohm होता है, which means that at 0 degree Celsius the RTD element should demonstrate 100 ohm resistance. Okay, this is the basic property, very important for the MCQ and also for your knowledge. So हम लोग क्या करेंगे, RTD मटेरियल का इनिशियल रेजिस्टेंस मतलब 0 डिग्री सेल्सियस में उसका कितना रेजिस्टेंस है, दैट इज known to us. You change, suppose due to the peripheral reason, due to the environmental causes, due to the surroundings, different factors, its resistance will get its temperature will get change. तो अभी क्या होगा, रेजिस्टेंस मेजरिंग डिवाइस उसका साथ एक कनेक्टेड है आर्ट का साथ, which can measure the change in resistance of the RTD material. So if its temperature will get changed, corresponding resistance भी change होगा, and that change in resistance can be easily measured with the help of any kind of resistance measuring device, any kind of bridge. Okay, so you will be easily able to understand that its temperature is getting changed by measuring or by detecting or by noticing the changed value of its resistance. Okay, so in brief, this is the definition, or this is the way how a RTD work. Clear? Next is RTD material. Okay, so these are very important for the MCQ, specifically this part. Then we'll start discuss about the classification type of the RTD, as these are in your syllabus. So what is RTD material? Copper, nickel, platinum, I have specified already, are widely used metals. These three metals are having different resistance variation with respect to the temperature variations. Okay, so that is called resistance temperature characteristics. So platinum has the temperature range of 650 degrees Celsius, and then the copper and nickel have 120 degrees Celsius and 300 degrees Celsius respectively. Mark it, MCQ के लिए important. The figure 1 shows the basic characteristics. Okay, for platinum its resistance changes by approx 0.4 ohms per degree Celsius. MCQ के लिए important, 1 डिग्री सेल्सियस चेंज होने से इसका रेजिस्टेंस वैल्यू 0.4 ohm चेंज होता है. The purity of the platinum is checked by measuring R100 by R0. मतलब 100 डिग्री सेल्सियस में इसका रेजिस्टेंस एंड 0 डिग्री सेल्सियस में इसका रेजिस्टेंस, इन दोनों का रेशियो हम लोग निकालते हैं. इस रेशियो का एक स्टैंडर्ड वैल्यू है. इफ द measured value is almost equal to the standard ratio R100 to R0, you can say it is properly working, because whatever the material actually we are using for making the RTD, that should be pure. मतलब purity check करना एक बहुत important thing है to check whether the RTD is properly working or not. Okay, so here I have shown you, I have told you one way to measure the purity. So in the case if the metal or the material using to make the RTD is not pure, it will deviate from the conventional registration temperature graph. हम लोग का पास जो ग्राफ है, उस ग्राफ को देख के तो पता चलता है कितना टेम्परेचर चेंज के लिए कितना रेजिस्टेंस होगा. तो ये जो ग्राफ से, ओरिजिनल ग्राफ से हम लोग का रीडिंग डेविएट करेगा, so there will be error in the reading. So basically RTD material, copper, platinum, nickel, and the basic ways, the technique to check its purity. Okay, next is RTD, tip sensitive and stem sensitive type. Two basic types of RTD and corresponding diagram. Okay, diagram तुम लोग एक बार देख लेना. I am going to explain. Just a minute, give me time, let me share another slide. Classification of the RTD, important for the MCQ. Tip sensitive and stem sensitive type, two classification. The first one, that is the tip sensitive bearing RTD. You know what is bearing? Bearing is a mechanical setup, okay, which normally used to the device which is basically rotating in nature to make, to provide ease in rotation or to provide ease in mechanical operation of that particular rotating device. Okay, so the tip sensitive bearing RTD probe, do you know what is probe? Anyone, any idea? Mikhail, what is probe? Prajwalika, Supriti, Lopamudra, anyone? What is probe?
Wire.
What is probe? Supriti, Prajwalika Gurung,
Wire.
where? More specifically, Lopamudra, what is probe? Probe is basically a metallic lead. You know what is lead? You used multimeter. I think there you must saw what is probe. Okay, a metallic lead
Yes, sir.
which when is touched to a particular surface or any terminal, it is able to sense its electrical nature. Okay, whether the types of charges, whether its polarity, whether its resistive value, etc., etc. So the tip sensitive bearing probe, there is a probe in tip sensitive RTD, uh, is a tubular sensor. Okay, it's constructional type tubular, you know, it's a tube kind of thing in which the sensing element is encased in a copper alloy tip, मतलब जिसका ऊपर एक copper alloy tip रहता है, फर्दर उसका ऊपर जो मटेरियल जिसको सेंस करना है उसको हम लोग कनेक्ट करते हैं. This allows for increased accuracy and sensitivity to temperature changes at the point of contact in bearing. You need to remember, without contact it's not able to change sense the change. Inserted at an opening on the bearing housing, they are used. Basically its operational features, procedures are mentioned here. They are used in electric motors, very important, and generators for continuous sensing of the bearing temperature, because bearing का temperature एक पर्टिकुलर वैल्यू का ज्यादा हो जाने से उसमें प्रॉब्लम होता है, उसमें बहुत सारे हीट लॉस होता है, उसमें कुछ मैकेनिकल प्रॉब्लम्स हो सकता है. So avoid those problems, we employ this. So this is the tip sensitive kind of thing. Bearing sensors can be used with a fluid sealed adjustable spring loaded holder for proper loading in any depth. So it can be used for any depth hole to maintain the contact with the bearing surface. So basically this is the features. Variety sheet style stainless steel used to construct it, uh, make it isolated stainless steel, insulated epoxy glass, copper tip elements, single and dual, or single probe, maybe dual probe, दो probe. Platinum, copper, nickel are the basic material, and sheet diameter 0.188, 0.250, 0.215 inch. Leadware cable options. So you can use directly leadware, or you can use insulated cable too. Okay, application industrial electrical motor generator, very important. देखो डायग्राम देखने का कोई जरूरत नहीं है, प्रैक्टिस करने का एक बार देख लेना, बेसिकली एमसीक्यू क्वेश्चन आएगा. सो दिस पॉइंट्स आर important. So in stem sensitive type, where the sensing elements is located within a few inches of the stem, मतलब कुछ दूर में भी रह सकता है. Or the tip sensitive type, where the sensing element is within the tip, मतलब यही है basic difference. For the use above 600 degree, a platinum element is employed. तो ये क्वेश्चन आ सकता है to sense the temperature more than 600 degree, what kind of adjustment is done. So your answer will be for such type of question. A platinum element is employed for the stem sensitive element type RTD. currently this is only this is the only application of this element, okay, to measure the temperature more than 600 degree. So in brief, this is as per syllabus, this you need to study. I'll send this thing, okay. किसी का कुछ क्वेश्चन है तो बोल सकते हो. I am giving you 2 minutes, 2 to 3 minutes. Actually, I am going to take one more class today. If you have any doubt, then please tell me. Any question?
No,
One,
sir.
one is telling nothing.
Sir. No, sir.
Very well. I am stop sharing the screen. I am going to start another important thing in your syllabus that is called thermistor. Okay, just give me 2 minutes. Okay, let me open the document and share. Okay. Acha, do one thing. As I am taking 2 consecutive classes, so attendance will be considered or for 2 consecutive classes separately. Okay. Do one thing. You all please switch on your cameras so that I can take a snapshot because I have to take this document to principal or principal sir. Everyone switch on your camera so that I can take a snap. And how many students are there? Three only. Four was there, I think. Four were there. Mikhail, Lopamudda, Projolika, switch on the camera. अच्छा, CA2 के बारे में तुम लोग को पता है? When the CA2 is there?
No,
At
sir.
the end of the and at the end of this month, MCQ will be there. Okay, I will send you some model question. Okay, today. Okay, you can switch off it now. No problem. I hope you can see the screen.
Yes, sir.
Okay. Just a minute. So